Okay, we good. Ian, we good. Okay.
What is it that we can do that is unique, that is impactful? We are going to empower every individual to do more and achieve more.
That's what technology really is. It's possibility.
Listen. You have more power at your fingertips than entire generations that came before you. Tomorrow is here today. What will you do? What will you do with it?
So this is an augmented reality device called HoloLens.
Wow. People can really use it to take things to the next level. That's what technology is supposed to do. That can change the world.
Hello everyone, and welcome to our talk, The Age of Applied AI. AI is going to take a huge impact in everybody's daily life, embedded in everything we do. And this talk is really about where we came from and emphasizing that each of us has a huge responsibility in terms how we make AI work for good and ethics of how AI will work for everyone. My name is Henk Boelman, Cloud Advocate at Microsoft, and I live in the Netherlands. And I'm really excited to take you on this journey through the AI landscape, where we will find out what AI actually is and learn what is possible now.
And hi everyone, my name's Amy Boyd. I am also a cloud advocate at Microsoft and I live in the UK. Along with what Henk said, we're going to dive into the past, the history of AI. We're going to talk a bit about what we can do today with AI, and then we're going to use the saying, just because we can doesn't mean we should, and apply that to responsible AI.
We have divided this talk in 5 chapters. In our first chapter, Amy will take us through the history of AI. Then we talk with Seth Juarez about what AI actually is, see what we can do with AI, and dive into the ethics part. Let's not waste any time. Amy, the stage is yours.
Okay, so I want to briefly talk to you about where it all started, the history of AI. We're going to give you a few different segments. I highly recommend going and researching a little bit more yourself. But we'll start in 1950. In 1950, there was a gentleman named Alan Turing, and he created the Turing test. When he did this, he speculated about the possibility of creating machines that think. This could be said to be the first time we've truly started to think about this idea of intelligent machines. And it wasn't long after that in 1956, we saw the Dartmouth Summer Research Project. Now, the Dartmouth Summer Research Project was led by John McCarthy, and he got himself and a lot of his reputable colleagues together, and they started and named the field of artificial intelligence. They used this quote to proceed on the basis of conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. And so this was the original definition of AI, and we know that AI has changed almost its expectations and its definitions over time. So let's take a look at a little bit further on in the AI cycle. So from around this time, 1956, all the way up to the mid-70s, this was where we saw the gold rush of AI. This was where research was being extremely well funded, optimism was through the roof, and everyone was really excited about what this new type of technology, this idea of intelligent machines, could start to do. Some of the good examples include things like Shaky, the robot, who was able to maneuver and make logical reasoning tasks. We also saw what you could call the first chatbot, called Eliza, and Eliza was able to converse with people and people thought that they were talking to a human. We also had things like Block's World and all sorts of other different new AI ventures. But unfortunately, it didn't last too long. Through the mid-70s into the early 80s, we saw an AI winter. Now, in research, a winter means that funding stops to being given, so ceases to exist, and unfortunately, optimism is lowered on what is actually possible. This can happen for many different reasons. Let's explore a couple of them. So these 4 symbols show some of the issues that might have come up during that AI winter. So one being compute power, the limited compute power that we had in the mid-70s to 80s. Then also looking at combinatorial explosion. So this idea of the amount of parameters or the amount of options that need training in an artificial intelligence agent. This was too much given the power, and also when we start to really optimize algorithms, we start to see better choices of combinatorial explosion. We then start looking at the data. We take advantage so much right now of how much data we have available, data we can create even. At the time, there was not as much digital data, and this did hinder the process of creating some powerful algorithms. And then finally, framing the problem. So thinking about the question that we're going to ask of the AI. Were we asking the right questions? Were they narrow enough? Because we know that AI can be good at, incredibly good at one thing. It was also during this AI winter and with these issues that we saw quite a lot of criticism of approaches. So we burst through with huge optimism, but sometimes we do have to critique each other's work so that we can continue to progress. At the time, there was criticisms on the Turing test by John Searle and his Chinese room theory, but there was also criticisms based on things like Eliza being the first chatbot and whether it was ethical what Eliza was doing in all the different forms that it was available. During this time and as we progress forward, Marvin Minsky was known for talking a lot about scruffy versus neat AI. So neat AI being this idea that you have lots of different options and trees and logical reasoning behind the applications of AI that you would build. Scruffy AI became something slightly different. It was this first idea that you have an object, they describe it as a small bird. If you have a bird, there's this whole world that lives around this bird, all the different things that you associate with birds or that bird would associate with life. And that was the idea that people started to build. They built them into something called scripts or frames, and interestingly enough, it's said that this type of technology actually led to some progressions in object-oriented programming. Into the 1980s, we were starting to get somewhere in production. Expert systems were becoming really popular because they became the focus of AI, given their huge business impact. People were saving millions and they were finding it incredibly useful to their business processes. This was also the time, probably a little bit more behind the scenes in research, that there was the revival of something called connectionism. Now, myself and you, we might know connectionism actually by a better name now, which is the application of neural networks. So things like Hopfield net, backpropagation, and applying these different processes to neural networks was a real step forward and something that was being revisited. Just before the early 90s, AI hit another cold wind, let's call it maybe, over an AI winter, in the sense that these expert systems that were showing such value for large business were actually really struggling now to maintain them. The hardware was really specialised, and this was at a time where we were democratising other technologies. So we were starting to say things like a personal computer on everyone's desk and all sorts of other things in the space as well, that actually it was all about giving it to everyone and not keeping it for certain people. During this time and in the 90s, we started to find that a lot of different AI approaches would come out of things with faces or things with human-like appearances. This was the promise of AI, the introduction of robotics. And we started to see everything that came out of AI felt like it had to have a face, which was not always the case, and we know that now, that it doesn't necessarily have to have a face to be incredibly powerful. And during this time where we saw AI with a face, we also started to see all of those issues that we described in that first AI winter coming into fruition. We have much larger scale compute power, we have an excessive amount of data, we're getting better at framing the exact question that we want our AI to answer, and we have algorithms that are getting incredibly optimized for different approaches that you're going to use. And so all of these things meant we can keep pushing forward with AI projects. And so we kind of get to the now, and I have these pictures of jigsaw pieces because artificial intelligence started as a single area. Over time, it's broken down into different jigsaw pieces or different segments. That means different parts of the AI spectrum can be focused on in a certain way. It also means, if you've ever heard it, if someone says, oh, someone's an expert in AI, they probably absolutely are. But one of the interesting things is, what specific parts of AI have they been working in? Because they all follow and all cross-collaborate across the different areas. Sometimes AI can feel like too much of a broad term, and so these jigsaw pieces have helped us really understand what's possible with AI. And so in this segment, I've taken you on a really whirlwind tour. I highly recommend going and researching the history of AI yourself. It's fascinating. So now we've talked about where it's come from, I'm thinking we're going to go and explore a little bit more about what it actually is, AI.
It is so fascinating to see that AI has been around already for so long. From the first moment the term AI became a thing, and now we are creating self-driving cars. But I want to take a step back and talk about what AI actually is. Let's call our colleague Seth Juarez and ask what his thoughts are. Hi Seth.
Seth, you're on mute.
All right. Can you hear me now? All right. Okay. Hello there. My name is Seth Juarez, and I'm so grateful that Hank and Amy have invited me here to talk about a couple of concepts that I think are a good overview for how you should think about AI and machine learning. And what better way to do that than to have my handy dandy blackboard. So if you look over here on my blackboard, there's usually a couple of terms that are used interchangeably, but they're not exactly the same. The first one's AI. The second one is machine learning, and the last one is deep learning. It turns out that these things are kind of the same, but not really. So let's start with AI in general. So AI actually includes all of these other things that are noted here. AI actually has as a sub thing of it machine learning and then deep learning as well. So let me draw this out. And then finally deep learning over here. Now, here's the thing about each of these, because I want to make sure we know the separation. AI is actually a really old concept from the 50s. And it turns out that the AI that has worked the best and probably seems like the most intelligent are the things that we do like for games, like a computer playing tic-tac-toe and chess. These things turned out to be search problems, but intelligent search problems. And there were some cool algorithms like A** and Minimax, which were very good at doing these kinds of searches for games. And it turns out that the search space was fairly small. And so imagine a scenario where you could literally look at a move that your opponent was going to do, see all the moves that you could do, and then you could search for the best one. It turns out that the search space started to get large in certain classes of problems, like looking at an image and knowing what's in it. So machine learning is another way of doing AI, but instead of having a search space to crawl over, you instead give the machine examples of the right thing and it figures out what to do. There's some cool algorithms like decision trees, SVMs, K-means, naive Bayes, and of course, neural networks. These algorithms, basically you give it data and it produces this thing called a model. Now, deep learning and machine learning are fairly similar. Deep learning is basically a class of neural networks, but much deeper. Now, the depth of the neural network for it to be deep learning really depends upon the marketing person. But reality, it turns out that these classes of algorithms are very good at doing cool stuff with vision, with speech, and with text. Okay, so let's get into the process here, because I think for programmers, it's really easy, at least for me it was, to get confused about what's going on. And I'm going to talk now specifically about machine learning. So usually when we're writing something, we're writing a program, we have some sort of input, and then we write some sort of algorithm, right? And then the machine does some stuff, and then the out thing happens, whatever we want to put out. So for example, imagine a scenario where we're giving it a bunch of numbers and we're supposed to find the biggest number, right? The algorithm just basically does a search and then out comes the max number. Pretty simple. Now, the thing about machine learning, again, is that the search space is fairly difficult. I mean, how do you write a bunch of if, else, whatever statements or for loops to look at a picture and figure out what's in it? So what machine learning does is it swaps around what we traditionally see as the right way of doing things. So instead of having the algorithm here, we swap this over here. We put the output and the input in, magic happens, and out comes an algorithm. This is the basic part of supervised machine learning. Then this algorithm we can plug back in, and we're back to the way we did things before. And I think it's a pretty cool way to think about it. Now, to be super precise, and I want to make sure that we use the right terms, the thing that comes in is the data. The thing that comes out are what are called models. And so when you think of a machine learning model, think of it as a learned algorithm from the data that is able to make predictions or to solve the problems. And the things that go in here are specific classes of algorithms that produce models, like a neural network. And a neural network basically produces a bunch of numbers in a network such that when the data comes in, it is multiplied, other mathematical operations happen, and the output tells you how it wants to predict. Other machine learning algorithms like k-means don't really produce models, but they describe the data in a compact way. So it kind of could be thought of as a model. K-means, for example, will look at your data, and without any other information, it's able to group them in a precise way. Okay, so that is the summary, I think, of AI, machine learning, and deep learning. You can see here, they're all subsets of one another. When it comes to thinking about machine learning, we flip around the concepts of inputs and outputs and what actually generates the algorithm. And then for precision, when we're looking at the data science terms, the input and the output are the data that we give the system, and then the output are the models. Hopefully this is helpful. Thank you so much, Hank and Amy, for inviting me. We'll see you hopefully in a little bit.
Thanks so much, Seth. That was brilliant. So, Hank, even with Seth's brilliant AI demo, I think we still need to see it in action. It's time for a demo. Do you have anything that could illustrate how easy AI is?
I absolutely have. Let's dive straight into that. One of the great things that happened in the past years is that AI moved from the research labs into a space where developers can use the power of machine learning without having data science skills. At the moment, there are over 50 cloud-based services available that expose an AI model through a REST API. These services enable you to add cognitive features like object detection and speech recognition to your application. By using the provided SDKs in the program language of your choice, like C#, Python and Java, you can create applications that can see, hear, speak, understand, and even make decisions. And probably you've seen a lot of these talks in the past years about these services. If not, go to ak.ms/age of AI, where we've created a guide to help you get started. Today, I want to show you a feature that not many know exists. Because some companies don't have the luxury to connect to the cloud all the time, or need control over their data. To solve that problem, some cognitive services are made available in containers. Azure Cognitive Services in containers give developers the flexibility into where to deploy and host these services. They come in Docker containers and have the same API experience as when they were hosted in Azure, but give you the freedom to run them into your own infrastructure. Let's watch a small video about this capability.
Every time a technology has moved from the hands of the few to a wide variety of people, a whole new set of capabilities that we never even imagined suddenly come into existence and change the world.
Cognitive Services enables developers to take advantage of AI without being a data scientist.
Some enterprises don't have the luxury of being able to call out to the cloud all the time.
Now with Cognitive Services in containers, that opens up a whole new world of possibilities.
Containerization is really the act of packaging up an application that you can take and put on any machine.
Azure is the only cloud that enables customers to take cognitive services in containers and use them on their own terms, in their own control.
I can go from a development environment to a production environment fairly quickly and build on top of that and expand that.
For example, a remote oil rig may not have bandwidth to transfer all of its data back up to a cloud solution, but definitely has strong needs.
Let's say that you are a hospital and you have tens of thousands of handwritten documents and you need to start processing those. With OCR in containers, you can actually run the models directly over the documents without sending them to the cloud and get a digital version of all that information. If I was in retail and I wanted to process customer feedback about my products, I could run that through language detection and key phrase extraction. Being able to process my text with sentiment models helps me to understand if what's being said is positive, negative, or neutral. This is enabling an entire new set of applications and use cases for our customers to use AI that previously was not possible.
It's really exciting to see what other people are building on top. That's been amazing to watch, and it's really honestly humbling.
I hope this video gave you an idea about the capabilities and when you can use it. And to demonstrate how easy it is to use one of those services, I've created a small demo where we're going to take a text-to-speech container and deploy them in an Azure Container instance. In this demo, we're going to run a Cognitive Service speech container in an Azure Container instance and use the REST API to convert text into speech. I'm going to use the Azure command line interface to create all my resources in my Azure subscription. The command line interface, also called the Azure CLI, is a set of commands used to create and manage Azure resources. The Azure CLI is available across Azure services and is designed to get you working quickly with Azure, with an emphasis on automation. Everything in Azure always starts with creating a resource group. A resource group is a resource that holds related resources for an Azure solution. To create a resource group using the CLI, you must specify two parameters: the name of the group and the location where this group is deployed. The next resource we are going to create is the Speech Cognitive Service. To create this resource, we need to specify a few parameters. Besides the name in the resource group, you need to specify the kind of cognitive service you want to create. For our demo, we are creating a speech service. When the speech service is successfully deployed, we can extract the properties we need for when we are going to run the container in the next step. The two properties we need are the endpoint URL and the API key. The speech service in the container is using these properties to connect to Azure every 15 minutes to send the billing information. One of the easiest ways to run a container is to use Azure Container instances. With one command in the Azure CLI, you can deploy a container and make it accessible for everyone. To create an ACI, it takes a few parameters. If you want your ACI to be accessible from the internet, you need to specify the parameter DNS name label. Copy-paste the billing endpoint and the API key. The deployment of an ACI should take around 5 minutes. The easiest way to validate if the container is running is to use a browser and open the container homepage. To do this, you need to retrieve the URL for the container first. This of course can be done using the Azure CLI. Navigate to the URL on port 5000, and if everything went well, you should see this page. To test our service, we need to create a post request. There are many ways to do a post request, but I'm using a program called Postman for this. In the request, we can specify the voice we want and the text we want to have converted to speech. Let's give it a try.
Hello world.
Nice, that worked. In this demo, I've showed you how you can run your own instance of the Speech API in your own infrastructure, giving you full control over the deployment and where your data is stored. To learn more about cognitive services in containers, visit ak.ms/Age of AI. I think this really shows how far we have come and how easy you can leverage the power of machine learning in your application. But with great power comes great responsibility.
You're absolutely right, Hank. And in this chapter, I wanted to talk a little bit more about responsible AI and some potential approaches we could take to it moving forwards. So let me ask you a few questions first. And when I ask you, would you trust an AI too? And then something on the end, I want you to really think about your immediate reaction to that question. So, would you trust an AI to recommend you a product or service? Okay, well, I use online shopping a lot, and so one of the things I find is those recommendations are often quite useful. They're quite targeted. They help me find something that I might like in a whole spectrum of different products. And so yeah, I would currently trust an AI to recommend a product or service. Okay, so the next question, would you trust an AI to help keep you safe online? This one's an interesting one, right? This one is, there are experts in their fields. They're probably much more of an expert than I am about different viruses that happen online. And so for something to be able to maybe flag things or tell me, when something's not quite right, or maybe act on it as well, I think I'm quite comfortable with that, given that I am not an expert. And so to hand that off to something that would be, it is something I would feel okay with. What about you? Have a think about it. So let's take a step up into the next section. So, would you trust an AI to assist your driving? This one's an interesting one, right? Until very recently, I would have been like, oh, I don't really know. But if something can help me know when there's going to be hazards, or if something can help me maybe like reverse into a parking spot or parallel park or something like that, then yeah, I'm more than happy for it to, as long as I have some kind of override capability, I feel fairly comfortable with that. So what about driving you? Would you trust an AI to drive you? This one is an interesting one. I'd say, oh, maybe, but then I think, oh, well, there's lots of car manufacturers out there that are creating autonomous vehicles, and we see them making their way through policies in various different parts of the world. And so I'm kind of like, yes, maybe sort of thing. I'm a lot closer to maybe yes than I am to anything else, but it's still an interesting one, right? It's still not something that I have personally tried. But I'm gonna go with a yes today with this one. let's speed this up and take a slightly different direction. So would you trust an AI to monitor your health? I'm not wearing it today, but I do have a fitness device. It gives me lots of interesting data and it can give me great insights. So yeah, I would be fine with it monitoring my health. Okay, but would I trust an AI to dispense medication? Okay, this one's a little bit different, right? So this one is, you maybe start to see my pessimism here, but dispensing medication, it's obviously very critical if you need that medication, and so there is that immediate question that comes to mind for me, which is what happens if it goes wrong? How am I alerted? There's a lot more for me to unpack there before I'm able to answer that one, and that's okay. That's okay to have questions about it. So this one is where we're going to go into a little bit of a case study. So would you trust an AI to help you choose a babysitter? So someone who's going to care for your child, your nieces and nephews, your family members, someone that you care for. Would you trust an AI to choose that person? Well, let me take you on a little journey where we can break down whether we would or whether we wouldn't, and what extra questions we might want to ask of would we trust an AI to help us choose a babysitter? Okay, so we have an example family here, and they are looking to choose a babysitter for their child, and there's lots of people in their area that might be interested in doing something like this. And company X here, as an example, would go ahead, and the idea is they would evaluate based on these people's social media accounts whether they should be recommended for the job. Okay, so, and then we can see that there's lots of different things that they can actually measure each person by. So they take their social media account and they maybe look at things like, do they have disrespectful attitude? Is there any explicit content? What are some of their flags posts, etc.? And this is how they would bring together a score that would help you choose a babysitter. Okay, so before we evaluate our final decision on whether we would let company X choose as a babysitter, I want to talk to you a little bit about values and morals and what ethics, the word ethics, can break down into. Now, this is the word ethics not based on data, not based on AI, but just the definition of ethics in general. So you can see two different kind of sides: values based on the well-being of others, and values based on our own well-being. And under each of these categories, there's different things such as non-suffering, the ability for us to have autonomy, equality, virtue, so what are our core values, as well as trust and trust in others. So if these are all the different values that we have when we have ethics for humans, what can we do when we have ethics for AI? Well, that's where I'd like to introduce you to FATE: fairness, accountability, transparency, and ethics. FATE is actually a part of the organisation at Microsoft. You can look them up online, and they do a lot of research around this type of AI. One of the fascinating pieces when I first saw this framework by Michael Robson at Microsoft was the way that he broke each of these categories down into really core questions that we can ask ourselves of any AI situation. And so if we take an example of a few, please feel free to take a look at these in more detail afterwards. You can think about, is anyone being treated differently? Well, yes, I guess if you think of the situation with the social media account, the first people I think of is, what if someone in the older generation who doesn't use social media so much, does that discriminate them from not getting a good score, a bad score, any score at all in this system? That would be something I'd like to know more about. Is the training data just based on a certain type of age group? You could almost build on that previous conversation and say, well, who was it trained on? What kind of different people, what kind of outcomes were expected? So that's kind of in that fairness category. If we move on to accountability, there's this idea of, can we give feedback or challenge the results and the mechanism for that recommendation? Is there ultimately a human accountable for that final decision, or does it actually automate that part of it? If we move on to transparency, there's this idea that is it clear in this process to everyone involved that an AI is being used? Is it well described and understandable? Do we know its shortfalls is always an interesting one. Are we actually using it for an appropriate use? And then finally, ethical. Is there any social implications? Is anyone discriminated against when using this system? Could there be any unexpected behaviour or human monitoring that could disadvantage people? There's so many different ways you could dive into this framework and use it to analyse your different AI solutions, just like we can with Company X. This framework shows that every person has a role in building responsible AI and that this should be built in right from the first day. We've seen lots of different aspects of AI solutions so far in this session, but in the next chapter, let's talk a little bit more about whether you should build or buy an AI solution.
As we have seen in the previous chapters, there's a lot of things that you have to take in account when you're creating a machine learning model. So when you're starting with an AI project, it is always good to ask yourself the question, am I going to build an AI component or will I buy it?
And so if you think about the 80-20 rule, 80% of the problems that you might want to solve with AI can probably be solved with a solution that's already available in the industry. So a really good example of that is the Azure Cognitive Services. Let's take a look at a system where I take an invoice, analyse it, extract values, and then use them in an application. So here we are in the Azure portal, and the first thing we want to do is create a cognitive service that is the forms recognizer. To create anything in Azure, you go up to the menu and click create a resource. To find forms recognizer, you can simply search for forms and forms recognizer will come up. Click create and fill in some simple details in order to create this instance. Here's one we created earlier. Here's the icon for it. If we click into this resource, the main thing we're going to need to use are the keys and the endpoints in order to train and test our Forms Recognizer API. So what does the code look like when we start to train, retrieve training results, analyze a new form and get those results? Well, here's 4 simple curl commands that can get you started. So we need to start by training the model. To train the model, we're going to pass 5 example forms to the Forms Recognizer API, along with a content type, a subscription key, and then the link to the actual documents that I want to train on. I have 5 forms that look a little bit like this. They all have a similar format, but what we want to do is extract all of this specific information per invoice. Once I've trained my models, I can retrieve and review the training results. But one of the things that we definitely want to do is test our training, and that's where we can analyze a new form. We send it to exactly the same API, but this time we have the model ID and we pass that in from the previous calls. We pass it the content type, the subscription key, and then this time, instead of a link to the training documents, I want to send it to one single invoice to test. Once that's sent, to actually get the full results, you call the results API with the output of the analyzed form. So let's see that in action. We can see there's a large JSON response, and I can format that and view it by using Alt, Shift and F. And we can see that this call succeeded. It now has these key value pairs like name and address, etc. And as we continue down, we can see postcode, company, city, and so this has broken out all the information we need from our forms. Now I've trained the Forms Recognizer API, I want to build it into some form of automation. Here I'm going to use Azure Functions. I have some sample code that allows me to call my Forms Recognizer API endpoint using HTTP requests. I have those fields that we recognise from our form, and I've also added in some of the details such as URL endpoint, API key, and the specific model ID that I want it to recognise from. You can use the Azure option on the left in Visual Studio Code to publish this straight to an Azure function. Our Azure function is sitting inside the Azure portal, and when you go to the code and test option, you can actually test this in the portal to see if it works. So we've created a post method and we've provided it our test invoice just like we did with the curl commands, plus a SAS token that allows us to access it. In the terminal we can see that this executed successfully, and in the HTTP response we can see all of those key value pairs now nicely aligned from our JSON response from Forms Recognizer.
That looked great, but there was still a good amount of code to put together. Can you create an application that can leverage AI with no code at all?
Yeah, absolutely. So AI technologies, just like all other technologies, are making their way down the democratization scale. And so you'll start finding there's software as a solution offerings to the things that you're trying to solve. So packaging them into easy to use AI and putting it in everyone's hands. Let's take a look at exactly the same scenario, but this time we're going to use the Microsoft Power Platform and AI Builder. Here I am in the Power Automate Studio. This is part of our Microsoft Power Platform, a software as a service offering for creating flows, apps, and also something I want to show you called AI Builder. So if I scroll down here and click on Build Model, AI Builder allows me to create these tailored AI models and add them to my processes as well as my applications. So we can see there's lots of different types of AI, and we can also just go to some pre-built AI. However, we're going to go on forms processing in order to train it to recognize our Tailwind Traders invoices. I'm going to give this model a name. And click Create. I'm going to tell it some of the fields that I want to extract from this invoice. So I'm going to extract name, invoice number, and total. You can also add tables, like for example that we've got in our invoice. I'm going to click Next. Now I need to provide it my 5 training documents. I add them to a collection, and I'm going to upload them from local storage. They've uploaded successfully, and I can see a sample here. I'm now going to get them to analyse the document. This will identify structure, detect fields, and extract values and pairs. So it's analysed my form, and as you'll notice it's picked out where all of the text is. Now we need to select these fields so it can pair up the key value pairs. So for name, I'm going to highlight the name just here. For invoice number, I'm going to highlight the invoice number. And for total, I'm going to select the total. I've completed one document. I just need to do this on 5 other documents. You'll notice in the document, it's actually automatically recognised these fields for me. So that was nice and quick and easy. I'm going to click Next. We can now see my model summary, where the data's come from, and the details as well as the number of images that I've used to train. So I'm now going to train this model. It's going to learn about my forms so that I can submit new forms to it. We can see that my model has been trained. We can see a sample here. We can see the selected fields. Let's do a quick test to see what it does. We're analysing a form we've not seen before. we can see that it's picked out the name, the invoice number, and the total. In order to build it into, say, an automation or an application, we actually need to publish this model. Now our model is published, we can use this model, and I'm actually going to create a new app that inserts this specific forms recognizer component on the canvas. So if I click New App, we can see we've landed in an app and it's actually brought in this Analyze Forms Processor widget into just a very basic app. So the first thing I'm going to do is test it out. To test out an app, I can click on the play button. I can click on the Analyze button, choose an invoice, and we can see it's found the name, the invoice number, and the total. From here, I can start to personalize this app to look more like the Tailwind Traders application that their finance team will use. So in this chapter, we've seen the scale of building versus buying AI solutions. There's always trade-offs no matter what option that you choose, but knowing what is available to you is the first important step you need to take when building AI solutions.
This brings us to the end of our session. We've covered a lot of ground, from the history of AI, found out what AI is, and seen some great examples on how you can use AI services in your applications. I hope you enjoyed it.
If you want to continue your learning journey, go to aka.ms/age-of-AI to find out more. Thanks so much.
With the right tools, ideas become the next innovation.
My idea is to prevent patients overdosing on prescription drugs.
I want diabetic patients to be aware of when they might get heart disease.
I'm trying to increase awareness about organ donation.
Microsoft helps ideas take flight.
Imagine a soil being able to tell the right quantity of nutrients it needs.
To help people with heart disabilities to live fuller and happier life.
Breaking through barriers.
We're trying to help people with disabilities lead more independent and inclusive lives.
Reaching across borders.
In India, organ donation is critical. If you don't get it on time, you could ultimately lose your life. I wanted to change that by introducing machine learning and AI.
Hi, Microsoft AI for Good.
Microsoft is putting innovation in the hands of people.
With our solution, the farmers can save up to 70% of weed killers.
We see a need to put AI in the process to empower doctors to analyze more patients. It will help them to detect critical cases much faster and preventing heart attacks.
Leaf AI is an automatic plant disease detection tool that can identify plant diseases with a simple smartphone.
To create change for the better.
Challenges like this allow people like myself to be able to bring our solutions to life.
I seize the opportunity and hope that others will use artificial intelligence to make this world a better place.